Okay, so pH and pOH scales. What you can see here is we have the scale. Are you familiar with the 0 to 14? Yes? To be honest, in grade 12, we'll learn that it actually will go higher and it will actually go lower, okay? But the typical range of pH is from 0 to 14. Those are typical values. You'll only get really high pHs if you have a lot of base, and you only get really low pHs if you have a lot of acid, okay? So the low end of the scale, if you have a 0, 1, or 2, are you acidic or are you basic? Acidic. So this end over here is acidic, and the other end over here is basic. And what ion is associated with acidity? What ion is associated with being an acid? Hydronium or hydroxide. So what that means is if something is acidic, then the concentration of H plus is high. If something is basic, well, there's two things we can actually say. We can say the concentration of OH minus is high, but also we can say that the concentration of H plus is low. Okay, and actually over here we could say the concentration of OH minus is low. So then the interesting thing to notice is that as pH gets lower, the hydrogen ion concentration gets higher. So you would think, oh, pH, I've got more, the bigger it is, but no, you have less hydrogen, the bigger the pH is. And we're going to find out why very shortly. It has to do with taking a negative log, okay? Now, yesterday we were looking at doing some dilutions. Do you remember that? Yes? And we took 10 milliliters, and in order to dilute it by a factor of 10, what volume did we fill it up to? We filled it up to 100. So a 1 in 10 dilution, a 1/10, will give you 1/10 the concentration. And this is going to be useful for pHs because every unit you move on the pH scale is actually times 10 in terms of the concentration of the hydrogen. Okay? So if you move from a pH 7 to pH 6, the hydrogen ion at concentration has actually gotten bigger by a factor of 10. Okay? 10 to the 1, in fact, because we have moved one space over. If our pH goes down by 2 units, so if we go from 5 to 3, our hydrogen ion concentration is actually 100 times higher. We moved over 2 spaces, so that's going to be 10 to the 2 times bigger. We move over 1 space, that's going to be 10 to the 1 times bigger. So as pH decreases, we get a bigger hydrogen ion concentration. As pH increases, let's say we have an increase by 1, 2, 3 units, okay, 3 units. That's actually going to be a concentration 10 to the power of 3 times smaller, okay? Or in other words, it's going to be 1/1000th of what it was originally. So to have a very low pH, you either have to have a strong acid, which is going to produce a high concentration of H+, or a very concentrated weak acid. Yes? Okay. High enough to produce a large hydrogen ion concentration, since so few of the particles of the acid actually dissociate. All right, so here is our strong acid again. There he is in his little Erlenmeyer flask. Okay, our little strong acid, it dissociates fully, and most concentrations are over here at a low pH. Now, carbonic acid, here's our little weak acid in the Erlenmeyer flask. There's not very many hydrogen ions, yeah, because most of it does not dissociate. So you'll have a higher pH. Okay, it's still an acid, so it will still be less than 7, but it just won't be like down at the 1 or 2 level, okay? Okay, so you guys are going to fill in this little chart here and see if you can do it on your own, and then we will check together. And feel free to refer back to the previous page if you need to. This is page 66. All right, so as pH increases, what happens to hydrogen ion concentration? It decreases. As pH decreases, hydrogen ion concentration increases. Yes. Now, this one was a little trickier, but did you figure it out? Yeah? As hydrogen ion increases, what happens to hydroxide ion? Let's go look. Back here, we said that, let's say we're at pH 0, that means hydrogen ion concentration is high. If hydrogen is high, then hydroxide is low. And we'll find out exactly why that is very shortly. Okay? And if hydrogen is low, then hydroxide is high. Okay? So they go like this, right? If one is high, the other's low. If one is low, the other's high. So as hydrogen increases, hydroxide decreases. And as hydrogen decreases, hydroxide increases. pH is a logarithmic scale. So if we were to double the pH, does H plus double? No. Okay, we'll find out what it does do, but it doesn't double. How many of you have done logarithms in math? Okay. Here's the nice thing in chemistry. If you did not like logs, all you need to be able to do is press the button on your calculator in Chem 12. Okay, that's it for being able to do logs in Chem 12. Okay, you don't have to do any log rules or any sort of proofs or anything. Okay. Now, for every change in the unit of pH, hydrogen ion concentration changes by a power of 10 or a factor of 10. You can say it either way, okay? So we have an example here. If the pH is increased from 2 to 4, so we start at 2 and we finish at 4. Well, the first thing we need to realize is that when we're given a pH, hydrogen ion concentration is equal to 10 to the negative pH. There we go. So if pH is 2, hydrogen ion concentration is 10 to the negative 2. Let's write that over here. Concentration of hydrogen is equal to 10 to the power of the negative pH. So if pH is 4, what is the concentration of hydrogen ion? It's 10 to the negative 4 molar. Now, if we wanted to write these as decimals, we could do that. We could say, okay, 10 to the negative 2 molar is 0.01 molar. And here we have this one is equal to 0.0001 molar. Now, to be honest, it's probably easier to look at these two numbers and tell how much the concentration has changed by, because you can just look at the exponents. You can say this exponent got smaller by 10 to the 2. Yes? It got smaller by 2 powers of 10. Okay? So the concentration, or this should say concentration of hydrogen, not pH. Fix. So concentration of hydrogen, has it increased or decreased as we went from pH 2 to pH 4? It's decreased, which makes sense. If pH gets bigger, hydrogen gets smaller. And it has decreased by a factor of 10 to the 2, which is 100. And it's okay to write it as 100. It's also okay to write it as 10 to the 2. Okay, either way is fine. Do you guys want to try the next one on your own? If the pH of a solution has decreased from 7 to 4, what has happened to the hydrogen ion concentration? Try that one on your own. guys know what it means when we say something is increased by a factor of? It means we multiply it by 1,000. If we decrease by a factor of, we divide by. Yeah? Okay. So hopefully your answer looks something like this. You can even just do that in your head. Very often this will be a multiple choice kind of question, and you can just do the math in your head. Okay? But if you needed to, you could show your work something like this. Okay? Have you ever heard of POH scale? No. It's exactly like pH, except for it is for hydroxide. Yes. So, for pH, we know that the concentration at pH 1, we have the concentration of hydrogen is 10 to the negative 1. At pH 2, concentration of hydrogen is 10 to the negative 2, and so on all the way up to 14 or beyond. But if we go to POH, the scale reads the reverse way. So if you are at pH equals 0, then POH is equal to 14. So it reads the opposite way. So pH goes the opposite direction. So if pH is 0, concentration of hydrogen is 10 to the 0, which is 1. And remember, if concentration of hydrogen is high, which 1 molar is fairly high in terms of concentrations, concentration of hydroxide will be low. And so you can see that we have 10 to the negative 14. That's a small concentration. That's 0.0000000000000000014. No, 1. Never mind. I don't know. I got excited by the 1,4. Okay. So you can take a look at these, and I would like you to take a look at each pair of numbers and tell me if you notice anything about them. Take a look at your pH and your POH. Take a look at your pH and your POH. What do you notice about each of those pairs? The sum is 14. The pH plus the POH always equals 14, at least at 25 degrees Celsius. Okay? So let's write that down here. At 25 degrees Celsius, pH plus POH is equal to 14. So that's going to be a handy thing to know, because you'll be asked to convert from pH to POH, and that formula is going to allow you to do that. Okay? Now let's take a look at neutral pH. Don't worry, I'll go back down there in a minute if you missed something. Let's go take a look at our neutral pH. pH is 7. Oh, look, POH is also 7, which means concentration of hydrogen is 10 to the negative 7, and the concentration of hydroxide is 10 to the negative 7. So the key thing, if something is neutral, what can you say about the hydroxide concentration and hydrogen concentration? They are the same, okay? So if something is neutral, concentration of hydroxide is equal to concentration of hydrogen. Over on this side, on the basic side, if pH is greater than 7, what can you say about the concentration of hydroxide and the concentration of hydrogen? Which one is bigger? If pH is greater than 7, hydroxide ion concentration is bigger. And that makes sense, right? Because those are basic solutions. So pH greater than 7 is basic. Hydroxide is bigger than hydrogen. Over here, I guess maybe I should point up at the thing here. There we go. If pH is less than 7, what can you say about hydroxide compared to hydrogen? Hydroxide is smaller, which means that your hydrogen ion concentration is bigger, which is why this is acidic. But when we are neutral, the concentration of hydroxide is equal to the concentration of hydrogen. Okay? Okay. So here's a lovely little picture, and it gives you just some typical things. So if you have 1 molar sodium hydroxide, up at the top here, it's going to have a pH of 14 and a pOH of 0. Let's actually take a look at that one. Sodium hydroxide, NaOH. Is it a strong base or a weak base? It's a strong base for metal. Remember, all metal hydroxides are strong bases. So what we can say is that's going to dissociate completely, and we'll end up, who are the products of that dissociation? Sodium ion and hydroxide ion. Now, if we have said that our concentration of NaOH is 1 molar, then what will the concentration of sodium ion be? We have a 1 to 1 to 1 ratio, yes? So concentration of sodium will also be 1 molar, and concentration of hydroxide will be 1 molar. And guess what? Hydroxide ion concentration is equal to 1. What is that as a power of 10? 10 to the power of 0 molar. And how do we find pOH? Or sorry, OH, concentration of OH minus is equal to 10 to the negative pOH. Just like we had 10 to the negative pH for hydrogen, this is 10 to the negative pOH, so it's just equal to 0. Okay? Household ammonia, pH 12. Toothpaste, pH 10. Baking soda, pH 8.5-ish. Pure water, pH 7. Urine is actually a little bit acidic. Black coffee, 5. Cola or vinegar, 3, which is why if you drink a lot of pop, it's really hard on your teeth. Or if you drink a lot of juice, because they both have a lot of acid in them. Okay, and acid tends to not be kind to your teeth. Gastric juices, yummy. pH of 1. pH of 1 is our gastric juices, and then 1 molar hydrochloric acid, pH of 0. Ooh, here's a good one. What do we get for each of these? What do we get for each of these? Here we have concentration of hydroxide is 10 to the negative 14. Is the bell going to ring? Is that why we're all like excited? Not quite yet. 46. Okay. Concentration of hydroxide is 10 to the negative 14. At the same, and that same solution, concentration of hydrogen will be 10 to the 0. What do you get if you multiply concentration of hydrogen times the concentration of hydroxide? That's going to be 10 to the negative 14 for hydrogen, yes, times 10 to the 0, or I'm sorry, I've got them backwards, don't I? Maybe, yeah, this should be 10 to the 0. Sorry about that. 10 to the 0 times 10 to the negative 14. And what do we get? 10 to the negative 14. Let's pick any other one on here. Shall we choose neutral pH? Let's see what we get. Concentration of hydrogen times the concentration of hydroxide. What do you get? 10 to the negative 7 times 10 to the negative 7 is 10 to the negative 14. And let's just try this one here. We have concentration of hydrogen times hydroxide, and we have 10 to the negative 9 hydrogen matches up with 10 to the negative 5 hydroxide. And what do we get? 10 to the negative 14. Oh my gosh, the value is always the same. So you know that just like pH plus POH equals 14, you also know that hydrogen times hydroxide is equal to, and I'm going to write it as 1 times 10 to the negative 14. And because that is constant, constant. What do you think we might call it? We might call it a K. And in fact, this one is the Ka for water. Because if we look at water on our data pages, look at that. Water dissociates into hydrogen and hydroxide. Yes? And water itself is a liquid. Do we include liquids in KEQ expressions? No. So Ka for water is concentration of hydrogen times concentration of hydroxide. Oh, and look, what value do we have here? Whoa, look at that. 1 times 10 to the negative 14. Coolio, yes? All right, and you're not going to worry about pH over the weekend. You are going to make sure you are an expert on dilutions, okay? So go home, read this, do the questions. We will revisit pH when we meet again next week.